Welcome to part 1 of this video where we will explore the velocity and acceleration at different points in a velocity time graph. In part 2, we'll explore the distance and displacement traveled throughout the motion. Let's start by setting up a graph for our scenario. So we have velocity on the y-axis, and the units are meters per second, and we have time on the x with units of seconds. Let's just create a simple scenario of somebody out for a walk. At time 0 seconds, they have a velocity of 0 meters per second. Over the course of the next 2 seconds, they accelerate to a velocity of 2 meters per second. After that, they maintain this velocity of 2 meters per second for 1 second, before slowing down, coming to a stop, and then accelerating in the negative direction to a velocity of -3 meters per second. They maintain this velocity of -3 meters per second for a half a second, before once again slowing down and coming to a stop at time 8 seconds. Let's quickly place some emphasis on our 0 meters per second line and run through this graph quickly one more time to make sure we completely understand it before the analysis. Our person starts with a velocity of 0 meters per second at time 0. They accelerate to a velocity of 2 meters per second over a time span of 2 seconds. At this point, they maintain their velocity of 2 meters per second for 1 second between 2 and 3 seconds before slowing down while still moving in the positive direction. Remember, here they're going 2 meters per second, positive 2 meters per second. A half second later, they're going positive 1 meter per second, and another half second later, they're going 0 meters per second. So although they're slowing down, they're still moving in the positive direction as they do this, from positive 2 to positive 1 to 0. After the 0 point, the person starts accelerating in the negative direction. So here they've come to a stop, and they start accelerating in the negative direction until they reach a velocity of -3 meters per second, before maintaining a velocity of -3 meters per second for half a second. And finally, the person slows down their velocity in the negative direction, going from -3 meters per second back to 0 meters per second, or not moving. So during this acceleration, this slowing down, the person is still moving in the negative direction. So they're moving in the negative direction at -3 meters per second, then at -2 meters per second, then at -1 meters per second, and then they finally come to a stop. Now that our graph is all set up and we understand it, let's answer 7 commonly asked questions about velocity time graphs. In question 1, we'll answer, what is the magnitude of the person's maximum velocity? In question 2, at what time or times does the person have a velocity of 0 meters per second? In question 3, during what time or times does the person have an acceleration of 0 meters per second squared? Question 4, during what time or times is the person's acceleration positive? Question 5, what is the magnitude of the person's maximum acceleration? Question 6, what is the total distance traveled by the person over the motion? And finally, question 7, what is the person's total displacement over the motion? In question number 1, we're asked, what is the magnitude of the person's maximum velocity? Well, remember, we're looking at a velocity time graph, so we can just read this off the graph. The max velocities occur at the peaks and the troughs of our graph. So here we have a peak with a velocity of 2 meters per second, and here we have a trough with a velocity of -3 meters per second. Remember, the negative sign only indicates direction of travel, so the largest magnitude of velocity is 3 meters per second. So our answer to question 1, what is the magnitude of the person's maximum velocity? It's 3 meters per second, occurring here between 5.5 and 6 seconds. For question 2, we look at what time or times does the person have a velocity of 0 meters per second. Again, we're looking at a velocity time graph, so we can just read this off the graph. So our person starts from rest here at a velocity of 0 meters per second and a time of 0 seconds. They then speed up maintain a velocity of 2 meters per second before slowing down, coming to a stop again here at time 4 seconds, before speeding up in the negative direction, maintaining a velocity of -3, and then again slowing down in the negative direction before coming to a stop again. So at what times does the person have a velocity of 0 meters per second? Our answers to number 2 are at time 0, at time 4 seconds, and at time 8 seconds. Next, for questions 3 through 5, we're asked to answer questions about the acceleration of our motion. To calculate the acceleration from a velocity time graph, we have to find the slopes of our different segments. Slope is equal to rise over run. If we look at the units of our graph, we have units of rise of meters per second, and we have units of run of seconds. Meters per second divided by seconds is equal to meters per second squared. These are the units of acceleration. We can label our segments quickly so we know which segment we're talking about when we refer to it. So this first segment here, we'll call it segment 1. This flat segment here, we'll call segment 2. This downward segment here, we'll call segment 3. This small flat segment here, we'll call segment 4. And this upward segment here, we'll call segment 5. Now we're ready to use this equation of slope is equal to rise over run to calculate our acceleration of our various segments. So for segment 1, we have a rise of 2 meters per second and a run of 2 seconds. So we have a rise of 2 meters per second and a run of 2 seconds. This gives us a slope in segment 1 of 1 meter per second squared. In segment number 2 here, we have no rise because we maintain a velocity of 2 meters per second. So we have a rise of 0 meters per second. And we maintain this velocity of 2 meters per second for 1 second, between 2 and 3 seconds. So we maintain this for 1 second. 0 meters per second divided by 1 second gives us a slope of 0 meters per second squared, or no acceleration. This should make sense. We're maintaining a velocity of 2 meters per second during this time. We have no acceleration. For our third segment, we actually don't have a rise, we have a drop. We have a drop of -1, -2, -3, -4, and -5. So we have a drop of -5 meters per second. And this drop occurs over a time of 1 second, 2 seconds, 2.5 seconds, 2.5 seconds. -5 meters per second divided by 2.5 seconds gives us an acceleration of 2 meters per second squared. And let's not forget the negative sign. Our acceleration of -2 meters per second squared makes sense because we're initially here at a velocity of 2 meters per second. We slow down or negatively accelerate until we come to a stop, and then we start negatively accelerating or increasing our velocity in the negative direction until we hit our velocity of -3 meters per second. In segment 4, we're again maintaining a velocity, this time -3 meters per second. So again, we have no rise in segment 4. Our velocity changes 0 meters per second. And we maintain this velocity over a time from 5.5 to 6 seconds, or a half a second. 0 divided by 0.5 gives us an acceleration of 0 meters per second squared. Similarly to segment 2, this should make sense. We're maintaining a velocity of -3 meters per second. There is no acceleration. We're not changing our velocity. And finally, in our fifth and last segment, we have a rise of 1, 2, 3, and we have a run of 1, 2. So in our fifth segment, we have a rise of 3 meters per second and a run of 2 seconds, giving us an acceleration of 1.5 meters per second squared. Although we're in the negative side of the graph, it's a positive acceleration because our car is slowing down or positively accelerating. So it's slowing down here from -3 to -2 to -1 to not moving. So this is a positive acceleration. We're now ready to answer our questions, and by solving all our slopes up front, it makes answering the questions a lot more straightforward. So in question 3, we're asked, during what time or times does the person have an acceleration of 0 meters per second? Well, now we can just look at our calculations. We had an acceleration of 0 meters per second here in segment 2, which was between 2 and 3 seconds. So between 2 and 3 seconds, and we have an acceleration of 0 here in segment 4 between 5.5 and 6 seconds. In question 4, we're asked, during what time or times is the person's acceleration positive? So in segment 1 here, we have a positive acceleration of 1 meters per second, and this happens between time 0 seconds and 2 seconds. Segment 2, we have an acceleration of 0 meters per second, which is neither positive nor negative. Segment 3 has an acceleration that's negative. Segment 4, again, 0 meters per second squared. And segment 5, again, has a positive acceleration of 1.5 meters per second squared. So this happens between time 6 seconds and 8 seconds. When do we have positive accelerations on a velocity time graph? Well, it's when the velocities are either getting more positive or trending towards positive. I always say to find out if your acceleration is positive or negative, if you were to run this all the way to infinity, where would you end up? So this line, if we continued it all the way to infinity, we'd end up at a positive velocity. Similarly to this line here, if we ran it all the way to infinity, we'd end up at a positive velocity. This line, if we ran it all the way to infinity, we'd end up at a negative velocity. So this would actually be a negative acceleration. So that's another way to think about the accelerations on a velocity time graph. In question 5, we're asked, what is the magnitude of the person's maximum acceleration? Remember, the positive and negative signs just indicate direction, so we can ignore these when we're finding the maximum acceleration. Particularly here where we're asked for the magnitude of the maximum acceleration and not the direction. So we're just looking for the biggest number. Well, our maximum acceleration happens here in our steepest line here at -2 meters per second squared. And since we're just asked for the magnitude and not the direction, we give our answer for the magnitude of the person's maximum acceleration as 2 meters per second squared. We leave off the negative because the question's not asking for direction. Looking back at questions 3, 4, and 5, we can come to some conclusions. In question 3, we're asked, what times does the person have an acceleration of 0 meters per second squared? These are where our lines are flat and have no slope. In question 4, we're asked, during what times is the person's acceleration positive? These are lines that have a positive slope as defined in mathematics. In question 5, we're asked, what is the magnitude of the person's maximum acceleration? Well, in the future, we can just look for the line with the greatest slope, and this will always give you your maximum acceleration. Thank you for watching this video on velocity time graphs, where we explored the velocity and the acceleration at different points. If you'd like to further explore this velocity time graph and find the distance and displacement over the motion, please watch part 2 of this video.